Hey guys, welcome back to lecture series on probability distribution. Within that guys, I already explained some of the important distribution in our channel. So from few days we are solving the example from chi-square distribution. Okay, so I already explained the method, some of the important example for your ENDSEM exam. So if you are interested to see these videos guys, go and check in my playlist. So you can see here in I button, or you can get this video in my description box. Okay, so guys, in my today's video I'm gonna explain to you all one of the very much important example again for your ENDSEM exam. Okay, so focus on this example guys. I'm telling you all these are the probable example for your ENDSEM exam. Okay, so you'll get the good marks from such examples. Okay, so here see that mostly repeated example is 2023 and 2022 latest question, mostly repeated for 5 marks. Okay, so without further ado, let's get dive into our today's example. So what we have given, a nationalized bank utilizes 4 teller windows. Okay, 4 teller windows. That means see that we have one of the nationalized bank which is having 4 windows. Okay, 4 windows. That means whenever we go for some of the work in bank, we do that work from the window, small window. Okay, so one of the nationalized bank are having 4 these windows. Okay, to under fast service the customers. Okay, to render fast service the customers on a particular day. Okay, so there is a one particular day, it has been observed. Okay, it has been observed that that day has had 800 customers. Okay, they were found in the 4 bank windows. Okay, yes, they were found in the 4 bank windows. Okay, so the window expected customer as per the window that the table we have given in example. Okay, that means table window number 1, window number 2, window number 3, window number 4, and the expected customers are in the window which are given. Okay, so in our first window they observed like 150 customers. In second window they observed 250 customers. Third windows they observed 170 customer. That means these are the expected customer as per the window. Okay, so you all are given that the total number of windows and expected customer in our window. Okay, so observed customers are not given, so that we have to figure it out. Okay, so total number of 800 customers were found. Okay, now see that these are the expected customer as per the first window, and we have to test whether the customers are uniformly distributed over the window. Okay, so what we have to find out here the customer are uniformly distributed over window or not. Okay, and we have to check it's a hypothesis. Okay, and whenever you are working on the hypothesis guys, need to remember that we use a chi-square distribution. Okay, and chi-square distribution, also the value for chi-square distribution, it is always there in your example, chi-square distribution. Okay, and it is 7.815. Okay, this one is our given value. Okay, yes, now see that guys, we don't have total observed frequencies. Okay, observed frequencies, so we have to find out the total observed frequencies. Okay, yes, for that you have to consider some of the hypotheses. Okay, like customer are uniformly distributed over windows. Okay, customers are uniformly distributed. So how we have here first solution. Okay, let me write the part of solution. Customers are uniformly distributed. Okay, customers are uniformly distributed. Customers are uniformly distributed. Now see that how many customers we have. Total customer 800. Okay, uniformly distributed means, now see that, let me explain the meaning of uniformly distributed. Using this one we are going to define observed frequencies. Okay, so we have total 4 windows, 1, 2, 3, 4. Okay, we have total 4 windows in our bank. Okay, and we have to distribute 800 customers uniformly in these 4 windows. Okay, so how we are going to define? We have to define the way that customer need to be uniform here in first window, second window, third window, and fourth window. Okay, so that means how you're going to distribute uniformly, that means all need to have equal outcomes. Okay, first window need to have 200 customers, second window need to have 200, third window need to have 200, and fourth window need to have 200. Now see that this is the complete uniform distribution of a customer as per the 4 windows. Okay, I hope you all have understood how I distribute uniformly our customers into our 4 windows. Okay, these are the 1, 2, 3, 4 windows there. So we have to distribute 800 customer into these 4 windows. Okay, first window has 200, second 200, third 200, and at last 200 customers. Okay, as per the 4th window. Now see that this one is our observed frequency, guys. Okay, so out of 200 expected 150, out of 200 customer expected 250. Okay, that maybe sometimes it can exceed. Okay, it can exceed than 200. It is not like that only the 200 customers can report in one window. Okay, maybe it can exceed more than this, or it can go less than this. So we have to define the observed values. Okay, expected observed value, that how many customer can be possible using 800 customers. Okay, so in our second window, out of 200, maybe there are some exit, we got the 250 customers. Again in next window, out of 200, it is possible that 170 customers are there, and out of 200 there are 230. Okay, so now see that these are the expected number of customers. Okay, so we got the all EI over here. Okay, or E1, this one is a E2, this one is a E3, and this one is a E4. Okay, these all expected all E4 customers. Okay, and observed frequency, this one is a O1, this one is the O2, this one is a O3, and this one is a O4. These are the 4 observed frequencies. Okay, yes. Now we want here chi-square distribution. Okay, chi-square distribution. Yes, let's define chi-square distribution. Chi-square distribution, we know that k minus p minus 1 can be written as summation of I, which is equal to 1 to k. Okay, OI minus EI, observed frequency, minus expected frequency, bracket square divided by EIs. Okay, it is not square, EI only. Okay, so see that we want all these values here. So take it separately. Okay, let me write the OI front of the EI. Okay, so I'll take this one to this table only. Okay, so I'm going to write OI here, observed frequency 200 for first, second 200, third 200, fourth 200. Okay, so we got the observed frequency, expected frequency. Okay, so we want the OI minus EI, bracket square. Okay, OI minus EI, that we want here in formula. Okay, that I'm defining here in the table only. Okay, so OI. Okay, OI minus EI, 200 minus 150. Okay, so see that. So here, sorry guys, I did little mistake here. Observed frequency means we have observed here 150 and expected 200. In one window we expected 200 of customer, and observed customer are there 150. Okay, yes, it is just little correction. Okay, because as it is given in expected number of customer in our example, it is not meaning that these are the expected values. Okay, these are the observed value. These are the O1, O2, O3, and O4. Okay, these are the OI. Okay, and expected, how we expect in one window, out of 800, 200 are expected. These are the 200, these are the 200, and these are the 200. Okay, they are the expected, but within expected we observe 150 observed. Okay, these are the observed. So we got the observed frequency, we have given the observed frequency So we got the expected frequency, find out the observed minus expected. Okay, so 200 minus 150. Okay, 200 minus 150, so we get the minus 50. First we get the minus 50 bracket square, second 50 bracket square, third 200 minus 170, 30 bracket square, and fourth 200 minus 230, like minus 30 bracket square. Okay, these are the OI minus EI bracket square. Okay, I hope you all have understood, guys, how I have written over here. It's not difficult, but need to understand what is the observed and what is the expected. So most of the time in example that they trick us, okay, like given as expected, but actually these are the observed. Okay, what we are observing in our window, these are the observed values. So we expected 200 customers on that particular day, but on same day we observed 150 only. Okay, we expected 200, but we only observed 150. Okay, similarly when we expected 200 customers, okay, when we expected 200 customer, but we only observed their 250 observed 250 customer. Okay, so I hope you all have understood observed and expected difference. Okay, yes, as we have 4 different values. Okay, so let me take it to the given formula. Okay, yes, so what we have, OI minus EI bracket square. Okay, that means O1 minus E1 bracket square divided by E1 plus O2 minus E2 bracket square divided by E2 plus O3 minus E3 bracket square divided by E3 plus O4 minus E4 bracket square divided by E4. See that, guys, these are the 4 values, okay, that we want here. So O1 minus E1 bracket square, we have here minus 50 square, O2 minus E2 50 square, O3 minus E3 30 square, O4 minus E4 square minus 30 square. Okay, let's put this value. So minus 50 square plus 50 square plus 30 square plus minus of 30 square. Okay, and total divided by E1, E2, E3, E4. Okay, E1, E2, E3, E4. These are the expected, okay, that we are expecting these many customers per window. Okay, total divided by 200, total divided by 200, total divided by and 200. Okay, yes, I hope you have understood how I have written this chi-square of k minus p minus 1. Okay, okay. So if you're going to define the value or calculate the value, you will get the chi-square as a 34. Okay, chi-square as a 34. So see that number of parameters, how many parameters we have here, total number of all the parameters k, which is equal to 4. Okay, k which is equal to 4, and we don't have p, we don't have given p, so consider p as 0. Okay, so if you're going to replace this value, chi-square of 4 minus 0 minus 1, that means 3. Chi-square of 3 is a 34. Okay, chi-square of 3 is a 34, and it is obviously we can see that this one is the bigger as a chi-square of 3 with respect to 0.05 as alpha. Okay, 0.05, it is a 7.815. Okay, so this one is the value that we received in our table, which is a more bigger than our required chi-square value. Okay, so that means we reject this value. Okay, so you just have to mention we reject this value. Okay, we reject this value as a H0, it is more like a 5%. Okay, that means the conclusion here, the customer in the nationalized bank may not be uniformly distributed over the window. Okay, may not be uniformly distributed, maybe they are distributed randomly. Okay, they are not uniformly distributed. Now see that, guys, this one is our entire solution. I hope you all have understood everything here in my today's lecture, guys. Nothing we have here difficult. Okay, so even after guys, if you found anything difficult, okay, if you feel that now this concept is difficult to understand, guys, please let me know in my comment section. I will come up with the similar videos. So that's it here for my today's lecture, guys. I hope you all understood my entire lecture. If you want to note this example, okay, take the note of it, write down the part which I explained. This one is very much important for your ENDSEM example, guys. Okay, so see that this one is our required solution. Pause the video, guys, note it down and take it for your final preparation. Okay, this one is everything about the chi-square distribution. I hope you all have understood everything. Even after, if you found anything difficult, confusing, not to understand concept like a difficult, let me know in my comment section, guys. I will come up with a similar video. So thank you everyone, thank you for my today's lecture.